quantumness of your cell phone using actor network theory by Bruno Latour, ANT for short. In this video, we focus on Bruno Latour's ANT theory, how it provides a lens to examine quantum phenomenon at play in your cell phones. Quantum dash storytelling weaves through the fabric of modern technology, particularly in the ubiquitous cell phone, an interplay of electrons, photon, and material sourcings that reveals a complex dance that enables not only remarkable capabilities, but dire consequences. Actor network theory, or ANT, highlights the interconnected nature of the quantum effects in cell phones, computers, GPS. It encompasses the non-localized nature of electrons, the relativistic time, wave-particle duality, quantum tunneling. All of these effects can be found in your cell phone. So quantum physics underpins the functionality of these pocket-sized marvels. Today we look at 5 aspects of actor network theory, or ANT as it's called. Number 1, not in the same place, not isotropic. Fits your cell phone, remarkable computing power. Electrons are oscillating and jumping from place to place at specific frequencies and amplitudes with other electrons in multi-places. And these quantum mechanics, these transistors that are reduced smaller and smaller to just the distance of a few atoms, exhibit wave-like properties, including quantum tunneling. It allows electrons to pass through barriers in one part of your memory chip to another, and those chips store those electrons for years, and they can be called out as your images of your family members and whatnot. Number 2, electrons not in the same, not synchronistic in terms of their time. It changes our view of space-time mattering. It reveals time slows down near these massive objects or goes at massive speed of light. GPS accuracy in our cell phone depends on satellites and these clocks, atomic clocks collecting time-encoded signals from cell phone towers and beaming them to our cell phone, our pocket computer, and relays our position for our GPS. Look at the 3rd aspect, not the same optic, not synoptic. There's discrete energy states of particles and these materials in a cell phone, the transistors in a cell phone that are made. It raises complex materials issues about conflict materials in the supply chain that produce the cell phones that you buy from these major brand manufacturers, Apple, right, Motorola, all the rest of them. Smartphones and other quantum-enabled devices rely on earth elements such as tin, tantalum, tungsten, the 3 T's, plus gold, and cobalt from parts of the earth ridden with human conflicts, sexual violence, all kinds of duplicity as companies are cheating in the way they put rocks into sacks and tag them as if they're controlling for child labor when child labor is so rampant, and the abuse of women and other men workers to get these scarce resources. There's a technology between the technological progress of iPhones coming out every year and the sustainability goals of the earth. 4th, not the same material agency. They're not homogeneous. We talked about these materials, right? Tantalum, tungsten, tin, gold, cobalt, right, in the armed conflicts. But we need to talk about something else in this 4th area of the semiconductor industry. Materials of all different types are laid together to create an amount of switching in the device, the flow of electrons in the current applied voltage, atoms and electrons, waves of light interacting, so we see screens. We'll get more into this in the fifth aspect of ANT. Smartphones display kind of a vibrant, high-resolution screens, touch screens, vibrating cell phones, interacting with colors as we touch the screens.
Number 5, not the same pressures of these
materials. The device
materials.
detects minute changes in electron properties. Information is then translated into action within the phone's operating system, and you are presented with approximately 3 million individually controlled microscopic light emitters, LEDs, that convince your eyes on the wavelengths that the eyes have of seeing reds and greens and blues, and your finger applies a small amount of pressure on the glass protective screen. The screen, does it sense? What is below does the sensing? This is some of the mysterious aspects. In some, smartphones harness quantum phenomena to deliver powerful capabilities in a compact device. Nanoscale transistors getting smaller and smaller, innovative LED display screens, crucial role in mobile phone technology. What's the future of quantum mechanics in cell phones? Well, one, researchers are developing quantum sensors to detect environmental pollutants. Two, we can monitor resource extraction of the conflict minerals put in our cell phones, in electronics manufacturing. We can, as consumers, look at our own complicity in ethical issues of these cell phone manufacturers, the use of the quantum technologies. We need to balance innovation with responsible sustainability and development. It's an ongoing challenge, right? Yes, it's about Einstein relativity, Niels Bohr, quantum mechanics. Yes, yes, yes. But these theories and challenging our intuitive sense of storytelling, space, time, and mattering, are opening ideas to revolutionary concepts and technologies. Quantum-storytelling is a trademark of this group, and we use quantum storytelling to understand and trace where materials come from in the world and how they're used, and the effects that are historical, social, and cultural on the way we live our lives. So this is David Michael Boje. I've been studying storytelling for 4 decades and quantum storytelling for 2.5 decades, and we have an annual conference in Las Cruces, New Mexico, every December. And you could come here and you could participate, you could present. Go to davidboje.com/quantum. Learn all about it. Bye for now. Thank you for listening.